Welcome back guys. Welcome back in another video tutorial for microbiology with Shagnik. So today we will going to talk about the basic properties of allosteric enzyme. We have already done a introductory video on allosteric enzyme. So if you have no idea about what is allosteric enzyme, then I will like to recommend you to please watch the first video of allosteric enzyme, then come here, then it will be very useful for you for understanding. So although I will going to give some quick recap of allosteric enzyme basic introduction. So what is allosteric enzyme? Allosteric enzyme are those that have two binding sites, right? One for substrate, another for modulator or allosteric effector, right? That modulator can be activator or inhibitor, right? That is why the regulation of those type of enzyme is depending on which modulators are binding with that modulator binding site, right? So various type of examination of the kinetics of those enzyme and various type of examination on the physical properties of allosteric enzyme, we have found that the activities of allosteric enzyme, as I have just told you, is totally depending on the metabolic activators or inhibitors. When activator bind to the allosteric site, it will create a impact in the substrate binding site in such a way that substrate can easily bind. Okay. Similarly, if inhibitors bind to the allosteric binding site, then it will create a impact on the substrate binding site in such a way that it will prevent the substrate to bind. So you can understand how much sensitive the allosteric enzyme activity is to metabolic activators or inhibitors. Now, the allosteric modulators, which are activators or inhibitors, can bind with the allosteric binding site by non-covalent interaction, although they remain unaltered after the enzymatic reaction. And what they will do, they will either alter the Km of the enzyme for the substrate or Vmax of the enzyme. Okay, I hope you can remember that if Km increases, then the affinity for the enzyme for the substrate decreases, right? So increasing Km is not good for us, right? So the main goal of a allosteric inhibitor will be to increase the Km, right? Similarly, for a allosteric activator, the main goal will be to decrease the Km, right? So that is the idea how allosteric modulator works. And as I have just told you, that is the modulator will be remain unchanged chemically by the enzyme. Now, the main important thing that most of the allosteric enzyme are having quaternary structure. That means they are consisting of multiple subunits, right? And the interaction between the each subunits is the basis of allostericity. Okay, that is the very important and key line of the entire chapter, because you may find in various times that allosteric modulator as a substrate binds with one subunit of the enzyme, and then it will create a impact in the next subunit substrate binding site. Similarly, again another substrate come here at the substrate binding site of one subunit of the enzyme, it will create a impact in the next case. So that is how it works. That is why the interaction in each subunit is very important, and it is the basis of allostericity. Now, at least for one substrate, you may find that the V0 versus substrate concentration curve looks like this curve rather than this curve, which we have studied in case of our Michaelis-Menten equation. And this curve is the indication of allostericity. This curve is the sigmoidal saturation curve. Okay, so we will going to talk about this sigmoidal saturation curve and its kinetics in our next part of the video, where we will going to talk about the Hill equation. So that's the idea, and they exist in two major conformational states, relaxed states and tense state. So that is the properties of allosteric enzyme. So for a quick recap, allosteric enzyme have two sides. One is substrate binding site, another one is regulator binding site. Regulator may be activator or inhibitor. If activator binds, it will change the substrate binding site in such a way that substrate can easily bind with that substrate binding site. Similarly, if inhibitor come here and bind, it will change the substrate binding site in such a way that substrate cannot bind, right? Now, those type of regulators will bind with the regulatory site via non-covalent interaction, and they mainly target the Km and Vmax of the enzyme. Not only that, those regulators will remain unchanged by the enzyme, okay, especially chemically. And this type of allosteric enzymes are quaternary in structure. That means they are having multiple subunit, and the interaction with each subunit is very, very important and the basis of allostericity, right? And for if the enzyme is allostericity, then for at least one substrate you will for at least one subunit you will get that the V0 versus substrate concentration is sigmoidal rather than the hyperbolic curve we used to observe in case of our Michaelis-Menten equation, right? So that is the idea of our basic properties of allosteric enzyme. So in the next video, we will going to talk about Hill equation and the sigmoidal saturation kinetics in detail. So till then, bye bye.